Hello all, let's talk pancreas. So the pancreas is in your gut, kind of right below your stomach and above your small intestines, and it produces a lot of things. Really two sets of things. The vast majority are in the first set, exocrine. And the exocrine secretions, in this case, digestive enzymes and alkaline-rich fluid that's going to get dumped into your small intestines, we're going to ignore those. We're going to talk about them later during the digestive system chapter. What we care about now are the endocrine secretions from the pancreas, and those are produced in the pancreatic islets, which means, again, small islands. So little islets in the pancreas that produce endocrine tissue. These are sometimes called islets of Langerhans. And within there you have two sets of cells, and each of them produces a type of hormone. You have alpha cells, which produce glucagon, and beta cells, which produce insulin. Each of those cells is producing something that's going to regulate glucose levels in your blood. Insulin reduces glucose levels in your blood by causing your cells to take up glucose to use it, and also by causing excess glucose to be stored as glycogen, which is a polysaccharide in your liver, in your muscles, and then some stuff to be stored as fat. Glucagon causes you to increase blood glucose levels. So we take all that stored stuff that we stored because of insulin during mealtime, and when it's been a few hours since we've eaten, we break down all that glycogen and release the glucose back into the bloodstream so that we can have energy for the rest of our bodies. And this is essentially what those islets of Langerhans look like. Here's another one of these homeostasis figures that we're looking at. Again, we're going to see a lot of these in this class, a lot during this chapter because the endocrine system helps maintain homeostasis in a lot of ways, but every chapter will be looking at how the body maintains homeostasis of one characteristic or another. In this case, if blood sugar goes up, right, like let's say I just ate a Chipotle burrito, right? My beta cells are going to secrete insulin in response, and that is going to cause cells to take up glucose and use them to make ATP. It's also going to cause excess glucose to be made into glycogen in the liver. It's going to cause us to build things. It's like, when it's payday, you have money to spend, right? So you spend it, you buy the things you need. Your cells do the same. All that causes blood glucose to go back down. When it's been a few hours and your blood glucose level drops, your alpha cells in your pancreatic islets secrete glucagon, and glucagon causes you to break down that glycogen in your liver and in your skeletal muscle again and release the glucose it produces into your body. It may also cause you to break down fats if you're running out of glucose, and then your blood glucose level goes back up to normal. There's an excellent video about how this works, again, in your BioFlix on your Mastering A&P. Now, we all know that this can go wrong, specifically with a disease called diabetes mellitus. And diabetes, the name, has to do with increased urination, right? This is because if you have excess blood sugar, you end up having excess sugar or glucose in your urine as it's being produced, and that's a solute. And like we talked about with sodium, water follows solutes. So if you have more sugar in your urine, you will have more water in your urine, and that means more urine, right? You just have more fluid to get rid of. And so one of the first signs of diabetes is that you have to urinate a lot. If you have hyperglycemia, presence of abnormally high blood sugar, you're probably going to have glycosuria, meaning glucose in urine, and polyuria, meaning excessive urine production. Way back in the day, before you could just pee on a stick or do a blood test, one of the ways that doctors could test for diabetes or glycosuria is they might sniff your urine or even take a little taste and see if it tasted sweet. Or if that sounded too gross for you, you could pour a little urine on the ground and see if ants came for it, because ants come for things that are sweet. And typically, you should not have any glucose to speak of in your urine unless you just ate a bunch of cotton candy. Now, there are two types of diabetes mellitus, type 1 and type 2. Type 1 diabetes is often called juvenile diabetes. Usually shows up when you're young, although not always. And this is a situation where you do not produce enough insulin. And it turns out the reason for this is that it's an autoimmune disease. So your immune system attacks the beta cells of your pancreatic islets. You no longer produce enough insulin, and therefore your cells can't take up enough glucose. You don't store that glucose as glycogen, and so your blood glucose level is just very high. That's type 1 diabetes, and it's usually treated now by shooting insulin into your body artificially. In type 2 diabetes, you're producing plenty of insulin. It's just that your cells have stopped responding to that insulin in a proper way. And so taking extra insulin doesn't necessarily help. And this is also something that usually comes on later in life. So it's generally called adult onset diabetes. And sometimes this can be treated with diet and exercise, especially if you have a moderate case. And this is important because there are a lot of things that come along with diabetes that can impact your health. So you can go blind, diabetic retinopathy, and you can lose parts of you lose toes and feet. I know I have older relatives who were diabetic who've lost toes and feet, and that has to do with issues in circulation that pop up when you have really, really high blood sugar. You're also at increased risk of heart attack, of nephropathy, so hurting your kidneys, neuropathy, so harming your nervous system as well. Very often, more than one hormone will have an effect on a particular characteristic. And so they're going to interact with one another in particular ways. One way they can interact is antagonistic, meaning they have opposite effects. And so both of them will kind of have a hand on the wheel to keep you straight, right? Maintain homeostasis. One pulls this way and the other pulls this way, and they counterbalance one another. Examples of this are parathyroid hormone, which increases blood calcium levels, and calcitonin, which decreases blood calcium levels. Insulin, which reduces your blood glucose levels, and glucagon, which raises your blood glucose levels. Again, this is antagonistic effect. Sometimes hormones can push in the same direction, and this is called an additive effect. For instance, glucocorticoids, like cortisol we mentioned, have a glucose-sparing action, right? They cause many of the organs of your body to stop using glucose in favor of proteins and lipids to spare that glucose for your brain. Well, growth hormone can also do that. And so when you have growth hormone and glucocorticoids being produced together, you end up getting a much greater glucose-sparing effect. So they add to the effect of the other hormone. So here hormone 1 binds to its receptor, hormone 2 binds to its receptor, and both of them are increasing cellular activity to cause a particular job to happen. The third type of hormone interaction is permissive. So this is kind of like additive, except instead of both of them doing the same thing, you need both of them for that thing to happen, right? So hormone 1 needs to be present for hormone 2 to do its job. So epinephrine can increase the rate of your cellular energy consumption, crank up your metabolism, which makes sense, right? Fight or flight. But it can only do that if there are thyroid hormones present, which are also important for metabolism. So without hormone 1 present, right, thyroid hormone, hormone 2, epinephrine, cannot increase cellular activity. This is permissive, right? It's slightly different than additive, where both are just pushing in the same direction. Here, one is sort of unlocking the door, and the other one is pushing the door open. The fourth and final type of hormone interaction is called integrative. And in this case, you've got hormones that are doing slightly different things, but they have the same ultimate effect or work together in some way. So analogy would be like, I am cold, I want to warm up. I could go about that in a couple of ways. I could put a sweater on, I could turn the heat up, right? Either one of those things would warm me up, but they're different things, right? So you can also look at a particular cell and you have two different hormones. Hormone 1 activates one enzyme complex, hormone 2 activates a different enzyme complex, but they both will contribute to one final goal. An example of this would be parathyroid hormone and calcitriol, which both will cause an increase in blood calcium levels, but they do it in slightly different ways. Hormones regulate a lot of different aspects of your body and homeostasis. I want to talk for a moment about blood pressure and blood volume, which influences blood pressure, right? You know, if you have more blood, right, that's more pressure pushing against the side of your vessels. And this involves a number of different organs. But if you have high blood pressure and you need to bring it down, your heart produces a hormone called natriuretic peptide, usually atrial natriuretic peptide because it's produced by the atria of your heart. Natriuretic peptide starts with Na, which means sodium. So this is the opposite of aldosterone, right? This is getting rid of sodium. And if you get rid of sodium, which is your main solute, water follows that solute, and so you end up getting rid of water too, and that reduces blood volume, thereby reduces blood pressure, right? So again, one of these figures. If we have increasing blood volume, you have stretching in these receptors in your atria, and you're going to produce natriuretic peptide, which is going to produce cause you to lose sodium and therefore water. It's also going to cause you to suppress thirst, right? You're not going to want to drink water. You're going to dilate your blood vessels, make them wider to temporarily reduce blood pressure. If you have low blood pressure and you need to increase it, again, one of the main ways to increase blood pressure is to make more blood. And you can make more blood cells by secreting something called erythropoietin, EPO, and your kidneys do this. And your kidneys also release something called renin to increase your blood plasma. So your kidneys are very, very involved in blood pressure regulation. So if you have low blood pressure, you will ultimately make more blood cells and retain more blood plasma. Renin kicks off a cascade of things that includes two other hormones called angiotensin and aldosterone. Aldosterone we've already talked about. That causes you to retain sodium, which means retain water, which means more blood volume, which means more blood pressure. Angiotensin, angio means blood vessels, that's what it refers to. And tensin means tension, right, to contract. So that causes you to constrict your blood vessels, and just like when you put your thumb on the end of a hose and squeeze it, make the kind of hole smaller, you get more water shooting out, right? So higher blood pressure results from constricting your blood vessels. So renin causes all these things to happen. To review, if your blood pressure drops, your kidneys will detect decreasing blood flow and decreasing O2. You produce erythropoietin to increase red blood cell production, means more blood volume. You will also increase renin production, which causes you to make more angiotensin and aldosterone. This means more fluid retention, more antidiuretic hormone secreted. You're going to be thirsty, so this is going to stimulate you to drink more water, which means more blood volume, which means more blood pressure, take you back to normal. You also have a lot of hormones that are involved in the long-term regulation of growth. And as you can imagine, there are a lot of organs involved in this, so there are a lot of hormones. So insulin, which helps you regulate blood glucose, right? That's going to be related to growth. If you can't regulate blood glucose, you don't have the energy to grow and build. A lot of growth involves bones. And so parathyroid hormone and calcitonin and calcitriol all work together to regulate the amount of calcium that you take out of your blood and put in your bones, or vice versa. So they're involved in growth. Thyroid hormones are involved in metabolism and glucose utilization. So you are requiring thyroid hormones to have the ATP to build up your nervous system, your skeletal system to get larger. And also reproductive hormones. Right? We know that, for instance, at puberty, we produce more estrogen or testosterone, and that causes us to shoot up, to grow. And finally, in terms of hormones related to growth, you can't skip over growth hormone. So particularly in children, this helps produce skeletal lengthening and muscle growth, and it helps adults in energy metabolism and storage.